Hey guys, in this video we would understand how to solve exponential equations. Let's understand this with an example. Let's say we have a question like 2 to the power of x plus 2 equal to 16 and we have to solve for x. Now whenever we are supposed to solve for x and x is a power, so that means it's an exponential equation, we try to make the bases common on each side of equal to sign. Here we have 2 to the power of x plus 2. Here also we would try to change 16 as a power of 2. So we would get 2 to the power of 4 is 16, and then we have 2 to the power of x plus 2. As soon as we get the two bases common, we can cancel them out and now we can just equate the powers. So we would have x plus 2 equal to 4. And that would give us x equal to 4 minus 2, that is 2. Let's take up another example. In this example, we have 5 to the power of 1 minus x equal to 10. Now we see that 10 cannot be changed as a power of base. So whenever this is the scenario, we can inverse the function. Inversing means we have to change the exponential function to logarithmic function. So whenever we would see that the bases cannot be made common, we would try inversing the function. And remember, this inversing is only helpful if we have x on only one of the equal to side powers. So when we inverse it, we would get log to the base of 5, because base of the power is 5, of 10, because we're going to interchange this and this, would be equal to 1 minus x. Now solving this is using the law that was log to the base of b of a, and we write it as log a over log b. So that's what we're going to be using here. We would have log 10 over log 5. That is equal to 1 minus x. Log 10 is nothing but 1. When you put this on the calculator, you'll get 1. Log 5, when we put on the calculator, we get 0.7. It's 0.69. We can round it to 0.7. That is equal to 1 minus x. When we divide 1 and 0.7, we would get 1.43. So here we get 1.43 equal to 1 minus x. X is equal to nothing but 1 minus 1.43. That is negative 0.43. So this is how we find out the value of x by inversing the exponential function. Inversing will give us logs, and inversing is only required if the bases cannot be made common. Let's take up one last example for the sake of practice. 4 to the power of x plus 1 plus 4 to the power of x is equal to 160. Now in this case, if we try changing 160 to base 4, it is basically nothing but equal to 4 times 4 times 10. Now 4 can be written as 4 to the power of 2, but 10 cannot be changed to base 4. Therefore, 160 cannot be changed to base 4. We cannot make the bases common. When we cannot make the bases common on each side of equal to sign, then we always try to introduce logs. Now, in the previous question, we inversed the question. Why? Because we had x on only one of the powers, but here we have x at two different locations. So we would first try to bring that x as 1x. So we would try to make x as a factor. And what do we do in that case is, we can split this up like this: 4 to the power of x times 4 to the power of 1. This is exponential laws. You must have done this in the previous grade. When you have the same bases and there is multiplication, same bases, there is multiplication between the bases, different powers, we can write down as a common base and we can add the powers. So this is nothing but 4 to the power of x times 4 to the power of 1. That's what we are writing it as. Plus we have 4 to the power of x equal to 160. Now both of these terms have 4 to the power of x as common. So we can take it out as a factor. We'll be left with 4 to the power of 1 plus 1 here. Nothing common means 1 is what we put, will be equal to 160. Now 4 to the power of 1 plus 1. 4 to the power of 1 is 4 plus 1 is 5, would give us this value. We just have to isolate for x. We'll move this over. So this is getting multiplied with 4 to the power of x. This would get divided by 160, and that gives us 32. We are left with 4 to the power of x equal to 32. We still cannot change this 32 as a power of 4. So we would inverse it. Now inversing is helpful because x is just at one spot. So we would write down log to the base of 4 of 32 is equal to x, and that can be finally written as log 32 over log 4. We just have to put this on the calculator, log 32 divided by log 4, and that gives us the value of x equal to 2.5. And that's the final answer for this. Let's do one last question of a different type. Here we see this is still an exponential function form, because this is written as a base to the power, this is written as a base to the power, and we have to solve for x. Now we see that x is at two different locations on either side of the equal to sign, and bases cannot be made common. And we know when the bases cannot be made common, we would have to change things to logarithmic form. And in this case, inversing would bring us only one side to logarithmic form, the other would stay as is. So in order to introduce logs on both sides, we would just put logs on. So put log on both sides. Again, remember, if log is written without any base, that means it is log to the base of 10. So we are putting log to the base of 10 on each side of the equal to sign. Now we know already there is a law of logarithm that's called the power law, that if we have written something as a power like this, we can bring this power out, so we can write it as n times log m. That's what we're going to be doing here. 2x times log 4 equal to 2x minus 1 times log 5. Now we would just collect the like terms, but before doing that, we see there are two terms here that are being multiplied by log. So we would first use distributive property to expand it. So basically we got 2x times log 5 minus 1 times log 5, which is log 5. This side of the equal to sign already has 2x times log 4. Now we can collect the like terms. We can bring this together, or we can bring this on this side and bring this here. It's up to us. So we would be doing 2x log 4 minus 2x times log 5 equal to minus log 5. This comes from here. We see here 2x is common. We can take that out as common, so we'll be left with 2x, and in the bracket we have log 4 minus log 5 is equal to negative log 5. We'll leave 2x here and we'll take this all on the other side. This is just algebra. We are isolating our variable, and this is what we get. Finally, we just have to put this all on the calculator and we'll see what we get there. So log 5, this is negative log 5. So negative log 5 divided by log 4 minus log 5, we get negative 0.7 over 0.6 minus 0.7. That gives us negative 0.7 over negative 0.1. Negative and negative gets cancelled. We're left with 7 is equal to 2x. So x is equal to 7 divided by 2. We can leave it as fractions or we can change it to decimals. It's up to us. So let's quickly summarize. If we have two x's on each side and we're solving for x, bases cannot be made common. We know we have to introduce logs, so that means we would put log. Base 10 is the best log, so we would put both sides base 10 log. Then we just have to apply the power rule, bring this power out, collect the like terms. Collecting like terms means x is on one side, number on the other side. We have two places where we see x, so those will come on one side. This negative log 5 is on the other side. 2x is taken out as common. We're left with log 4 minus log 5, and then we're just isolating for x. Here we're supposed to use calculator, and the final answer that we get is x equal to 3.5.